Hey, Curie Physics students, Mr. Crone here, and I'm going to help you today with the collection of data for one of our mini labs. We're going to look at the conservation of energy in little toys like a Super Ball, Mega Elf Flyer, it's an elastic guy, and one of these drop and pop toys. This is one that can store elastic energy and then release it when you drop it. So we'll look at both energy conservation, energy transformations, and then also energy loss from the systems. And I'm going to kind of help you to collect the data. You know, in the remote world, unfortunately, we can't get into the classroom to be able to collect the data, but I can help you out, so no big deal. So we're going to start with the Super Ball, and I've already measured the mass of all of these guys. So the mass of the Super Ball was 0.00642 kilograms. So again, 0.00642 kilograms. At any point, obviously, in the video, you can always pause it if anything that I ever said or that you were looking at you couldn't see, you're going to pause the video. And that's how we're going to collect the data today. So I have a meter stick taped to the wall behind me, and what I'm going to do is hold this Super Ball so that the bottom of the ball is lined up exactly with the meter stick, the top of the meter stick. So the bottom of the ball will be exactly 1 meter. It will fall exactly 1 meter, and then it will bounce back up. And let's see what that looks like. Okay, so it looks like around in here, somewhere in the 60s is where this guy ended up. So this is why I've lined up the camera to be level with the around the 60s mark, because that's where the ball is going to come up to. That's going to allow you from the video to be able to see how high the ball returned up to. Okay, I'll make the drop 3 times, and you'll record 3 heights, and then you'll take the average of those to get the average rebound height. And with that information, you'll be able to work out things like how much energy it had, how much energy that it had in the end when it bounced back up, and then what was the loss. It started at 1 meter, but it didn't bounce back up to 1 meter, so some of the energy must have gone somewhere else. Before we do that, let's do a quick review of the meter stick. All of you are pretty knowledgeable about how to read the meter stick, but just want to kind of remind people, the meter stick is a little weird because, right, this is 1 meter stick, and yet the numbers, when you look at them, the numbers are in the 60s, 70s, and 80s. The reason is because these are the centimeter numbers. Now, the millimeter numbers are the little fine lines right there. But in this case, you can read these in one of 2 ways. So if you read them in centimeters, you just read the number. So 60, 70, 80, and so on. But if you want the number in meters, all you need to do is put a decimal in front of that number. So this is not 60, this would be 0.6 meters, 0.7 meters, 0.8 meters. This would be 0.73 meters right there. So you can use it both in centimeters and meters. It's really quick and easy. You don't need to do a fancy conversion or anything like that. When you want to read in centimeters, you read the number. When you want it in meters, you just throw a decimal in front of there. Okay, so when I drop this, you'll see that it bounces up somewhere about in this region. And what you're going to want to do is, at this point, when I say that I'm getting ready to drop, you want to start putting it in slow motion so that you can see a little bit more clearly, and then try to pause it when you feel like it's reached its highest point, and then you'll measure what the value of that is. Remember, you're looking at the bottom of the ball, not the top or the middle, but the bottom of the ball. All right, guys, here we go. Here's drop number 1. Drop number 2. And drop number 3. Now we'll do one extra one just in case you couldn't see any of those. This will be a 4th extra drop just in case. Okay, looked like that guy got into the camera. So now we can move on to the data collection for the second part. What you should do is pause the video and finish the data for that first part, and then come back to the video. Okay, our second toy is this guy. He's a little challenging to work with. So what I'm going to do at this point is I'm going to kind of rearrange some of the meter sticks. So I need a second meter stick. I'm going to take this one down. Okay, and we'll put this one back up. But for now, let me put this meter stick up. And the reason why I want to move this meter stick up is because this guy jumps pretty high. So he can jump more than 1 meter in the air. All right, so I've got 2 meter sticks now. I'm going to move you up just a little bit higher so you can see a little bit better. I'm actually going to add a little bit of tape to make sure this doesn't fall on me. All right, now let's move you up a little bit higher so you'll be able to see the top of the meter stick just a little bit better. All right. Now moving a little bit closer. Now this one's going to be a little bit different. So what I'm going to do is I will put this guy, let's take a look down here. I will take this guy and I will push him down until he reaches the 10 centimeter mark before I let him go. So I'm going to make sure that the top of his head lines up with the 10 centimeter mark. Think about that. So we have to take into account that 10 centimeters. And I'm going to allow this thing to jump up in the air. You'll see it at the top. And remember, I was measuring from the top of his head. So that's where you want to measure too. If it turns a little sideways, no worries. Just look for where is the top of the head, and that'll give you a pretty accurate measurement. So let me move you back up to your view. Let's get you a little closer. Okay, and I will do several. I'm going to do this 5 times. You just want to try to make sure you can see at least 3 of them, and you feel like you were able to get a good measurement from those. So if you look really closely here, this is exactly 1 meter is the seam, and then here's 1.1, 1.2, 1.3, and so on. And I think you should see this guy is probably going to be up here somewhere just a little bit over a meter. All right, guys, here we go. Number 1. Number 2. Remember, I'm setting this for 10 centimeters, the top of his head. Number 3. Number 4. These are just extras. If you've got 3, that's enough. You can make your measurements from there. That was number 4, and then we'll do number 5. All right, getting him down to the 10 centimeter mark. Here we go, last one. Oh, jumped over my head. Okay, so remember, all you needed to get was 3 good measurements from that. All right, I'm going to actually back you up far away so you can see me entirely now. And let me show you something for that last toy. Now, the mass of the Mega Elf is right here. So the mass of the Mega Elf was 0.00402 kilograms. 0.00402 kilograms. All right, last toy is the Drop and Pop. So this toy has a base that when it lands, it's pretty hard. It is flexible, it's made out of plastic, but it's fairly hard. Now, on the other hand, when I fold it like this, you can see that little plastic piece now, it sits inside and now it's actually makes contact with the rubber. So when I drop this guy, oh, we can just do it like this. There we go. When I drop this guy, you'll see, without me doing anything, it's not too exciting. He bounces a little bit. Some of that energy gets stored and then re-released and turned back into kinetic energy, which sends it back up, and that transforms to potential energy. But you can see it's not very exciting. Doesn't jump very high. All right, so what we're going to do instead is we'll fold this guy so that he is stored some elastic energy. And what I'm going to do is I'll spin it just a little bit when I drop it, and that's going to just make it a little bit more stable. Let's look at what happens when I drop this from different heights. And let me give you the mass of that guy right now. This guy's mass is this is for the Drop and Pop, 0.02447. 0.02447 kilograms. Okay, I'm going to drop this from pretty low, down here around 50 centimeters. Let's see how high this guy jumps up to. Okay, it came up and just missed my ceiling, essentially. Let's try dropping it from 70 centimeters, see what happens. Oh, that wasn't a very good one. Let's try it again. 70 centimeters. Okay, it just touched the ceiling tile right here. Let's try it from 90 centimeters, see what happens there. It just came up and hit the bottom of my ceiling. Let's try it at 110 centimeters. It just touched the ceiling. 130, just touched the ceiling. 150, it just touched the ceiling. So just think about that for a second. It doesn't seem to matter where I drop it from. So when this thing jumps back up in the air, it's not coming from the potential energy, because if that were the case, I should see this guy going higher and higher as I give him more potential energy. But it doesn't seem to matter how much potential energy I give him. Even when I drop this guy way down at 50 centimeters, it goes up and just touches the ceiling. So I measured the ceiling. You can see these meter sticks are just a pinch short of reaching the top of my ceiling, and they're about 5 centimeters short. So the height that this guy will jump to is about 205 centimeters or 2.05 meters. So when you're thinking about how much energy must be stored in there, just think about the fact that he always jumps up to the same height, about 2.05 meters. You should be able to work out how much energy this guy has. All right, guys, that's everything. That's how the data was collected. You can go back and watch it again if you missed anything. And obviously just ask me or your teacher, and we will help you out.